Reduce rational expressions. Review reducing fractions. Remember that in order to reduce fractions, we divide out common factors. So if we were to have something like an example 1, where we had 24 divided by 15, we could break down 24 using prime factorization, and we would come up with 3 times 2 times 2 divided by 15, which is just 3 times 5. And then we would see that we've got this 3 in common in both the numerator and the denominator. Then we go ahead and multiply back together everything that's left. So we've got 2 times 2 times 2 would give us 8 on top and 5 on the bottom. And that will be our completely reduced fraction. Now if we look at this example 2, there's a little bit more going on in here. We've got 48 x squared y over 18 xy squared. So right off the top of my head, I'm not as certain how this 48 is going to break down, so I'll actually do out my factoring tree here. This is 12 times 4, and 12 is 3 times 4, and 4 is 2 times 2, and this 4 is 2 times 2. Okay, so now I can see that on top I'm going to have 3 times 2 times 2 times 2 times 2. Then I'll have these x's here, x times x, and a y. Then on the bottom, I'm going to have 18, and in order to actually do out the factoring for 18, I know that that's 9 times 2, and 9 is 3 times 3. So then on bottom I'll have 3 times 3 times 2, and then I have x, y to the third. So times x, and then y to the third will be y times y times y. So in this case, there's a lot more to be looking for in terms of matches on the top and bottom. So I see that I've got a 3 on the top and bottom, which can divide out, 2 on the top and bottom, which can divide out, an x on the top and the bottom, which can divide out, and a y on the top and the bottom, which can divide out. So then I end up left with, on top, 2 times 2 times 2, which is going to give me 8, and I've got an x left over. And then on the bottom, I've got just a 3 for the numbers, and y times y, which is y squared for my variables. So when I reduce this fraction, I come up with 8x divided by 3y squared.